That's okay. It was a last minute change, so I do apologize. You are stuck with me instead of Pete today. I've been working with Wilson Biochemical for a number of years now, and I'm currently the sales and marketing manager. So Wilson Biochemical has over 50 years experience in the design and supply of steam process systems. Our team has developed the Wilson solution. This is an autoclaving technology that treats municipal solid waste to produce sterile recyclables and, most importantly, Wilson fiber. Wilson fiber is an homogeneous biogenic fiber, and it's an ideal feedstock for a number of renewable energy developments, and we are continuing to learn about its capabilities within the bioenergy industry. The main highlights to remember is that we can divert up to 90% of waste from landfill. The system does not require any pre-sorting of waste, neither at home or at the curbside, as this can be done post-autoclaving. Each batch is the same. No matter the waste input, all of the biogenic material, so your food, your paper, and your cardboard, will be turned into Wilson fiber. And this has been tested and proven to have consistent results. Wilson fiber is an ideal feedstock. It's consistent and it's efficient. It's easily turned into pellets or briquettes for transport. It's readily adaptable to current combustion technologies, and it's proven to be a very valuable resource for bioenergy. Waste is a huge liability, and this is on a global scale. But it's more important to focus on the solution than the problem. The solution here is Wilson fiber, and this is where we can reap the rewards and play a part in creating a circular economy and have a real impact on sustainable development. Without going into too much technical detail, this will be a quick overview of the autoclave system. A commercial scale system can treat up to 150,000 tons of waste per annum, and this will be done through a 2-vessel system that treats 20 tons of waste per hour. The system is modular in design, so if you were to require to treat 300,000 tons of waste per annum, you would just need a 4-vessel system. When the waste arrives, it will be inspected and it's loaded into the autoclave. The waste will be treated with a dry saturated steam. And through the steam accumulator, we can inject the steam instantaneously into the vessels. The steam will be discharged into the autoclave and reach a top temperature of 160 degrees Celsius, and the waste will be treated for about 45 minutes. Under the control system, when the cycle is finished, it will go through a depressurization cycle. The autoclave will then rotate in the opposite direction, and the fiber and all the recyclables will be discharged into a separating system. Wilson fiber is the main output of the autoclaving system. This is all the recovered biogenic fraction of waste. So typically, between 55 and 65% of unsegregated waste will turn into fiber. It is important to remember that what you put into the autoclave, you will get out. If your batch of waste is made up of mostly biogenic material, you will have a higher fiber output. Again, each batch of fiber is the same. Years of analysis have proven the regularity and repeatability of its performance. When the fiber is unloaded from the autoclave, the moisture content is between 35 and 40%. This can be lowered through going through further drying processes. And on dried fiber, calorific value is about 18 megajoules per kilo. Wilson fiber can be used as a feedstock in current technologies like anaerobic digestion, gasification, CHP plants, and pyrolysis. And it proves to be more efficient as it's a consistent fuel input and achieves greater energy returns. We have received grant funding through Innovate UK for 2 projects. Our first project is to create biochar from the fiber, and this is to commingle or replace with coal. Once the fiber is produced, it will go through a torrefaction process, and it turns it into a coal-like substance. We are currently proving this as a fuel source that will act similar to coal without the harmful environmental impacts. Second, we are proving that Wilson fiber can be turned into acetone, butanol, ethanol, and hydrogen, and this will be done through hydrolysis and fermentation. In the next 2 years, we will have developed a demonstration facility that uses MSW as a feedstock for ABE production, with the aims of entering the transport fuel market. At the minute, those are our main projects. We are in discussions with various groups about potential uses of Wilson fiber within the high-value chemicals market, and we are very excited to learn about what else we can achieve. Now for the exciting part, for the policy advice. Unfortunately, there is no uniform waste strategy. Every council has different regulations about what can and cannot be recycled. This only leads to confusion and a contamination of waste that's an extra cost to all the local authorities when having to resort it. If the Wilson solution was implemented, we could return to a one-bin system. That being said, we do support recycling. It is important for society to play their role in creating a cleaner environment, but the Wilson solution can take out the consequences of basic human error. Secondly, we would like to see the stop of incinerators. Burning waste is an old and outdated method that's just being greenwashed, and it has adverse effects. So if we truly want to achieve a circular economy, we need to start extracting value from our waste, as we are proving it to be a valuable feedstock within bioenergy. Thank you.